family. Let's do this. Like I said, I'm going to ask you guys to disable your videos just for now. I can do it on my side here and maybe stop the videos so that there's no disturbance whatsoever from anywhere else. All right, on WhatsApp now, I'm sending the link to the YouTube channel, to the Facebook channel rather. We are live on Facebook and I'm going to send it now. Welcome to the Facebook family as well. Those are going to be watching us from different places. Welcome and hope you guys will enjoy today's lesson. And yeah, let's have fun. Enjoy ourselves and pull through from there on. Make sure that you get the link, the link for Facebook as well. I'll upload this thing on YouTube soon enough. Probably by the end of the day today, I'll have uploaded it. And you guys can have it and watch it at any time that you want. We are doing functions. So give me a second, I'll keep quiet for now. Just want to sort out one or two things. I will record the session content on your behalf. Don't worry, I'll record all that. And then I will send it to you guys. So don't worry, I'll definitely send it to you guys. The links and everything. So no need to worry about much. I definitely will do everything for you. All right, all of you are muted. In other words, I am the only one capable of talking and being heard. Now, during the session, if you have something to ask, you want to ask something, you can raise your hand using the platform. Zoom has an ability to make sure that you can raise your hand using the platform. So it's not much of a train smash. You can always raise your hand using the platform. Check it out there. There's a part where it says raise hand. It should be there. So if you want to ask something, you want clarity, you raise your hand, it pops up on my screen, then I can unmute you at any time. You can ask me whatever you want to ask me, and we'll take it up from there. Right. Those that can't hear me, right, let me just send a message now on the chat here to say, if you can't hear me, let's activate all the videos, please. Somebody send this on WhatsApp. If you can't hear me, just tell them to check the left-hand side of their device. There should be an icon for like earphones. Click onto that. In some devices, it says, just say click onto that icon for earphones, right? For headphones or earphones, whatever the case could be. Click onto that, you should be able to probably hear me from there on. Guys, we should be starting within the next minute or so that at least we can guarantee that we all understand and learn as much as we can. All right. All right, confirm if you can hear me again. I want to start the lesson. Confirm. Confirm with me if you can hear me again. I want to start the lesson. Sharp. All right, people, let's start. This is what I'm going to show. I'm going to share the screen right here. I'm going to share the screen, and I want to. Right. Let me know if you can see this. Just give me a sharp again. Let's see. Did you see what I just put across? Okay, good. That's fine. Okay, there we are. Right, let me start off with this particular part of our lesson. Now, these are called function practice questions. I'll send this document to you, whether you're watching on YouTube or on Facebook, or you'll watch on YouTube as well later, or you are on Zoom. I will be able to show you or send this to you. The question says the graph of f of x is equal to what you're looking at right there, and g of x, what you are looking at right there, are sketched below. The graphs intersect at -2, 0, as well as 4 and 6, right? That's what you have. That's fine. And then further on, you're given the diagram is drawn like this. I want to teach you how to deal with f of x greater than 0, f of x dot g of x, all those kind of things, so that you know what to do at any particular moment. So here's my graph. Looking at the graph, the first one is definitely, or g of x is a straight line, while f of x is definitely a parabola or a quadratic graph. Question number 1 says, use the graph to determine the values of x for which f of x is greater than 0. Use the graph to determine the values of x for which f of x is greater than 0. Very important. Now, if you look at this, let me help you understand this. When you're dealing with f of x being greater than 0, you're saying to yourself, you're looking at the parts of the graph of f where it's above the x-axis. One more time. When f of x is greater than 0, this is the part of the graph where it is above the x-axis. So it is this part here, this whole part. The graph of f of x happens to be above the x-axis. So when it's f of x is greater than 0, the graph of f of x is above the x-axis. The question says, use the graph to determine the values of x for which, right, f of x will be greater than 0. Let me explain this quickly. Now, if I look at the x values which contribute to f of x being greater than 0, which contribute to my graph being above the x-axis, it's from this portion here, like this. So from x -2 up to x as 6 here. So between x as -2 and x as 6 here, the graph of f is above the x-axis. So it says use the graph to determine the values of x for which f of x will be greater than 0. So my answer should be between -2 and 6. That's English. Between -2 and 6. Let's do it in math. In math, simple, your answer should be -2 is less than x, but that x is less than 6. So for 5.1, this answer for this question here, -2 is less than x and x is less than 6, suggesting to me that between the values of x of -2 and 6, your graph of f is above the particular x-axis as can be seen. That's 5.1. That's okay. 5.1, if there's any question whatsoever, again, you lift up your hand. I should be able to see you from this particular place where I am. Let's try 5.2. Quickly, let's try 5.2. So 5.1, again, I'm going to write it down. The answer is -2 is less than x. X is definitely less than 6 as well. Okay, beautiful. Right? There are people that are saying they can't see the screen. What you simply do is try to move out of your Zoom platform in a certain way, like your phone. Play around with the settings of your phone there on Zoom. You should be able to see me. It's because maybe you're on another application, that's why you can't see me. Should be able to see me from there. Let's go. The next one is 5.2. 5.2 says, use the graph to determine the values of x for which, again, f of x is equal to g of x. Beautiful. When f of x is equal to g of x, it's looking at parts of the graph where they intersect, where they meet each other, where they cut off each other. Look at this. Now, if you look at this particular part here, they meet here, the graph of f and g meets there, and they meet there as well. So every time you hear or see f of x is equal to g of x, automatically know that they are talking about a situation where the two graphs are meeting. And the question is, use the graph to determine the values of x for which f of x is equal to g of x. If you notice this, f of x is equal to g of x when x is -2. That will be my first answer, because they want the values of x which contribute to that situation. And also when x is equal to 4. So at these two portions, when x is equal to -2 and x is equal to 4, that's when the graph of f of x is equal to g of x, as can be seen. Write that one down. 5.2, f of x is equal to g of x. I'll send you this document. Don't worry about that. Okay, let's keep moving and seeing how far we can go, right? All right, let me write the answer again for 5.1. Someone didn't see that. 5.1, I'm going to write the answer. And it's actually -2 is less than x, but x is less than 6. 5.3, we're going. 5.3, I'm taking this out now. 5.3. Okay, we're learning, we're understanding. 5.3. Now in 5.3, it says the following to me. It says, use the graph again to determine the values of x for which g of x, this time g of x, is less than or equal to 0. G of x is less than or equal to 0. Now, g of x is a straight line graph. Now, when g of x is less than or equal to 0, we are talking about portions, parts of the graph of g where it is below the x-axis. So less than or equal to 0 means from 0 and below the x-axis. So I need to look for parts of the graph of g where it is below the x-axis. So I'm going to shade this out here. It is this part here. This whole part here shows me that g of x is below the x-axis. And that's what they're looking for, less than or equal to 0. But the question says, for which x values does that happen for? For which x values do you find g of x being less than or equal to 0? So if I look at this nicely, all the values of x from -2, like this, going this side. All the values of x from -2 going this side, all of them, give me a situation where g of x is less than or equal to from -2. G of x is less than or equal to 0. In other words, if I picked an x value here, it will be negative. I picked an x value here, it will be less than -2. I picked an x value here, less than -2. And for all these x values that I picked, g of x is below the x-axis. So for 5.3, when g of x is less than or equal to 0, it means I'm looking for values of x -2 to the left. From -2 to the left. That is the portion whereby my g of x, my graph of g, is below the x-axis. So here I'll write x is less than or equal to -2. Notice I said less than or equal to. Every time in the question they say less equal to, you must also put that sign there, equal to. So in other words, I'm agreeing that at -2, g of x is 0. But even from less than -2, g of x is less than 0. So you must be definitely less than 0. You must be able, from all aspects, to be able to say, okay, if from -2 going to the left-hand side, numbers that are less than -2 as it were. So 5.3, x is less than or equal to -2. Let's go to 5.4. Why I'm doing this is because I'm gonna be doing quite a number of questions, and they will have this part incorporated into them. So once we get this done, we'll be fine. Kilebohile, you raised your hand, and I'd like to recognize you. I'm gonna unmute you now, and all you need to do is just say something to me. Go ahead.
Good afternoon, sir. Okay, I wanted to ask that, is it wrong if I say it's from -2 to -infinity?
Very correct. It's correct to say from -2 to -infinity. That's fine by me. So that's okay. This is another version of it. Just want to teach you just one version. But again, what you just said is okay, because you're saying from -2 onwards, the graph of G is definitely below the x-axis. Let's try the next one there. I think there are about 2 more people that raised their hands. Let me just recognize them so that at least I can be able. All right. Who's that? Let me see. Makoma, you have your hand up, and I'm going to unmute you. Go ahead. Let me try that again. I'm going to try and unmute you. There you are.
Okay, can you hear me?
Loud and clear.
Okay, with the girl that asked the question before, right? With what she said, do we say x is an element of real numbers, and then we put a bracket from -2 to -infinity? Is that how we'd write it?
That's fine. That's also another version of writing this. Now, what you guys are asking me, there are different ways of writing this in the exam, and that's all good and well. The point for me right now is to be able to say, when I have a situation, which format do I pick? I'm just going to choose one format, this one of x -2 less than greater than whatever the case could be. I really don't mind that. That's okay. So what format you use, as long as it aligns to math, that's okay. I'm hoping I'm answering.
Okay, sir. From now on forward, is it okay with you to like just write both ways? Because I prefer the one with the x as an element of, so that we're on the same page, basically.
All right, I'll try my best to make sure that I pull through on all levels. The problem with math is there are so many ways of doing the same thing. So I'm not going to be able to exhaust everything and say, okay, guys, this is it. I'm going to do this one, this version, this one, this version. Let me try my best to pull through. Let me go to my next one. Let me see if I can work it out in a certain way. All right, let's keep going. We're going to, thank you so much for those questions. F of x, 5.4, f of x minus g of x is greater than 0. Okay, I want to write this down. F of x, okay, minus g of x, all right? So it's f of x, all right, minus g of x, okay? In that case, it says to me, it is greater than 0. Okay, I gotta get this done. Greater than 0. Now, let me teach you. This is what you do. So in this case, you got f of x minus g of x greater than 0. Take the negative g of x to the other side of the inequality sign. Make it jump. So it becomes f of x, right, is greater than g of x like this. That's what you do. That's the first thing. F of x is greater than g of x. So in English, this is how you'd interpret it. You're looking for parts of the graph where the graph of f is bigger, where the graph of f is on top of the graph of g. That's how you interpret this. F of x greater than g of x. You're looking for parts of the graph where the graph of f is on top, is bigger, is further on the graph of g. Let me show you which portion we are talking about on this one here. We're looking for parts of the graph again where the graph of f is bigger, is on top of the graph of g. Follow my lead. I'm going to shade it out. Look at this. The graph of f, where is it? On top. Greater than g of x. This portion here, from here to there, I need to justify why I'm saying that, right? I need to justify why I'm saying that. Follow my lead. Now, notice from here to there, from here to there. Okay, let me put lines there. From there to there. The graph of f is above the graph of g. The graph of f is on top of the graph of g. So it's at the top right there, and g happens to be at the bottom. So the key here is understanding that f of x dot g of x minus g of x, take the minus g of x to the other side, look for portions of the graph of f above g of x. And the x values that contribute to this scenario of the graph of f being on top of the graph of g, the x values that contribute to this scenario are from here, x as -2, up to here, x as +4. That's all. From x between -2 and 4, the graph of f is above the graph of g. Look at this, I'm trying to use my hands. The graph of f is above the graph of g from -2 to +4. So when you're writing it, you'll simply say to yourself, -2 is less than x, but that x is less than 4. That's what you do. -2 is less than x. So between -2 and 4, the graph of f happens to be greater above the graph of g. That's the answer to that question right there. We're learning. Let's keep going on this one, okay? Beautiful. I want to take this out clearly. Take this out, so it's going to be above, on top, and all that. Just as of interest sake, check this out. Of interest sake, I'm going to take out this drawing here. Right, of interest sake, look at this, family. Now, if you were to move from here, here, this side, notice that from x is greater than 4, the graph of g happens to be above the graph of f. From x, from 4 to the right-hand side, x greater than 4, the graph of g is the one above the graph of f. And if you were to come here, right, come here with me and move this side to the left-hand side. Again, the graph of g, which is this one here, is above the graph of f, and that's fine. So in every circumstance, please be cognizant of what you're being asked. Am I being asked about f being on top of g greater, or g of x the other way around, as can be seen? Sharp. Let's go to the next one. I'm hoping you guys are understanding or learning. 5.5 is interesting, as well as 5.6. As soon as I'm done with that one, we're going straight to a big question, or big questions that you're going to do with me, and all of them are on your handout that I gave you. F of x, 5.5, f of x dot g of x is greater than or equal to 0. F of x dot g of x, the divided by, is f of x divided rather by g of x, there you are. And it says it's greater than or equal to 0. Now let's think. Now f of x, these are the y values of the graph of f. G of x, these are the y values again of the graph of g. Now when they're dividing and they give you something greater than or equal to 0. When they're dividing and they give you something greater than or equal to 0. When two things divide and give you greater than or equal to 0, it's because one of them at the top is positive and the other one is positive. So positive divided by positive, you get positive, and a positive thing is greater than or equal to 0. Or it could be that at the top, f of x could be negative, g of x also negative, both of them being negative, and because both of them are negative, they give you something greater than 0. Let me say this. Let me write it down. Check this out. So in other words, I'm saying to you, you could have a situation of plus divided by plus, both f of x and g of x being positive, or negative divided by negative, both f of x and g of x being negative. So you're looking at circumstances where the graph of f of x can be positive and the graph of g of x also can be positive at the same time, or both these graphs are negative at the same time. Right, let's clarify. Eyes on the board now. Look at this. If f of x is positive, where is it from? I'm going to start here. I'm going to just put positive. See, from here, above the x-axis, f of x is positive. Above the x-axis, f of x is positive. Okay? Then if I go to another part there, okay, I got another part there. Here, f of x is negative. Below the x-axis, f of x is negative. Below the x-axis, f of x is negative, 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 negative. That's f of x. Let's try g of x and see if we're on the right track. With g of x, look at what we have. From here, it's negative. Below the x-axis is negative, 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 negative. Then after 2, when you're going to the right-hand side, it starts being positive, 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 so forth. What am I looking for? I'm looking for f of x and g of x. Either both of them are positive or both of them are negative, right? Let's break it down. Look at this. If you were to look at this portion from here to the side, from x is less than negative 2. The graph of f of x is negative, I agree. The graph of g of x is also negative, I agree. From x is less than minus 2. Both graphs of f and g, here's the x-axis, here's the x-axis. Both graphs of f and g, both of them are below the x-axis from negative 2 to the left. So the x values from negative 2 this side. The graph of f and g, both of them are below the x-axis. So your first answer is this one. X is less than or equal to negative 2. All right. I'm coming through to you. Help me out here. Two people have raised their hands. I'm going to come through. Allow me to finish this up. I'm going to come and attend to you right now. I see your hands. So the first part, when x is less than negative 2, the graph of f and the graph of g are below the x-axis. Both of them are negative. Let me try and see where both of them are positive, if it's there. Now, between negative 2 and 6, between negative 2 and 6, the graph of f is above the x-axis. The graph of g is also above the x-axis. From negative 2 and 6, just this portion. The graph of f above the x-axis, positive. The graph of g above the x-axis, positive. From where? From negative 2 up until I get to positive 6. So my next answer should be negative 2 is less than or equal to x, but x is less than or equal to 6. So in all circumstances, again, family, notice when there's an equal to, you must include it in your answer. There's my equal to, there's my equal to, and also there's my equal to. If your answer is between two numbers, like negative 2 and 6, start with the small one. Negative 2 is less than x, okay? But the same x is less than or equal to 6. That way, you will know that your graph of f of x positive above the x-axis, positive for g of x also above the x-axis. I see the hands there. I want to attend to them. Let me check you guys. Who's got their hand up? Percy, go ahead.
Good afternoon, sir.
How you doing?
I'm fine, and you?
Great, man. Talk to me.
At 5.4, sir, I wanted to ask, for instance, if it was a plus instead of a minus, if it was like fx plus g of x is
like
greater than or 0.
Fx like this plus g of x.
Yeah, is greater than 0. Would you have had
Okay,
to...
now I understand what you're talking about. Well, in such circumstances, this question will not be, you can't be able to solve this when it's f of x plus g of x. Because the problem is when you take f of x to the other side, it becomes negative. So it becomes a bit a problem to actually it out when it's positive g of x becoming negative. So for your questions and for your level, guys, you're only going to be getting f of x minus g of x, right? Or dot g of x, or f of x divided by g of x, or f of x greater than 0 or less than 0, whatever the case could be. Just basically that for your guys' level right now. So for that one, it won't be that possible. Thank you so much, Percy, for that one.
Thank you,
if someone
sir.
else got their hand up, you can mute yourself. I have Pumla. There you go, Pumla.
Sir, can you hear me?
Loud and clear.
I didn't get the whole f of x over g of x. Like, does the answer depend on what sign is given to us, like greater than or less than? Does it
Exactly.
Does it like
That.
depend on what values are we going to give based on the sign?
All right, good question on that one. Beautiful. So the answers, like you said, depend on the sign, the inequality sign that you're giving. Look at this. If somebody say to me f of x dot g of x is less than or equal to 0, just somebody says that, then in my head, I must say to myself, okay, if anything is going to be less than 0, then the top part can be positive and the bottom can be negative, or the top can be negative and the bottom can be positive. That way, you can get something less than or equal to 0. That's the only way you can do it, right? So in this case, ours was greater than or equal to 0. That's a positive number. How do you get a positive number when you're dividing two things? The first one must be positive at the top, so must be the second one at the bottom. How do you get something greater than 0? It's going to be negative, and then negative also at the bottom as well. So in that case, you can get a situation of positive, positive, negative, negative. But if it's less than 0, it's positive, negative, or negative, positive. Let me just clarify something further. Look at this. I see the hands raising up. It's fine. I'm coming to you. Imagine this one. If I say to you, f of x dot, now I'm multiplying, g of x is greater than 0. Just that. F of x dot g of x greater than 0. You're looking at portions of the graph where f of x will be positive, g of x is positive. Why? Because positive and positive gives you something greater than 0. Or you're looking at situations of the graph where both of them are negative. Because negative times negative, again, gives you something greater than 0. If it was the other way around, if they did this way, right? Let's say they said less than 0. Then I'm looking for parts of the graph where f of x can be positive, but my g of x will be negative. Because that's how you get anything less than 0. Or you have a situation whereby f of x is negative, but g of x is positive. It all depends on what the inequality sign tells you. That's the most important thing right there. The inequality sign will help you to know, am I saying plus and minus, minus and plus, or plus and plus, or minus and minus, depending on what you have in your particular question there. Right, allow me to move through. I don't see the hands anymore, but allow me to move through to the next one quickly, and I'll come back to the hands if they pop up again. Right, 5.6, the last one, then we go to a major question together. 5.6. 5.6 is interesting. It says the derivative f, and then the stroking at the top. Let me just write this. It says to me the derivative of f of x multiplied by g of x, okay, is less than or equal to 0. I like this. The derivative of f of x multiplied by g of x is less than or equal to 0. Now, there's a difference in saying f of x and in saying derivative of f of x. Huge difference. The derivative of f of x represents the gradient of the graph. That's the derivative of f of x. It represents the gradient of the graph. Derivative of f of x. I see your hand. I'm going to come to you now. Now, it says to me, the derivative of f of x dot g of x is less than or equal to 0. It means to me, I must look for portions of the graph where the gradient of f of x is positive and then g of x is negative. That's how you get less than 0. Or I'm going to look for parts of the graph where the gradient of g of x is negative multiplied, the kind of f of x, sorry, is negative multiplied by g of x, which is positive. So those are the portions of concern. Derivative of f of x is positive, while g of x at that same instance is negative. Or the gradient of f of x, derivative of f of x is negative, and g of x is positive. Okay, say, what does it mean when the gradient is positive? It means you are looking for portions of the graph where the graph of f is increasing, it's going uphill. So when the graph is going uphill, it means the gradient is positive. When the graph is going downhill, it means the gradient is negative. So I'm looking for portions of my graph where the gradient of f is positive, I'm going up, while at the same time, g is negative. Okay, let's do the math. Let's look at this. Now, if I start here, the graph of f is positive. Positive, it's going up. It's going up. The gradient is positive. Yes, true. It goes up anyway, all this way. Positive, positive, gradient positive, gradient positive, positive, and then it stops here. Gradient stops there. Now, obviously, this point here is a turning point. And if I look at my graph, let's just give it an x value of 2. So there's my 2. So it looks like if I was to deal with the positive section of my f of x, the positive section where the graph or the gradient is increasing is basically from this part to that whole part. Now, going down from here, from there, where I'm using the red color here, the gradient is negative. It's going downhill. So positive gradient from here to there, negative gradient from there to the bottom. Sharp. What am I looking for? I'm looking for parts of the graph where the gradient is positive, but at the same time, g of x, notice guys, not the gradient of g of x, g of x himself. G of x is negative. So when the gradient of f is positive, I'm going uphill. When g of x is negative, I'm below the x-axis. When g of x is negative, I'm below the x-axis. And so when I'm below the x-axis, I'm talking about this portion here for g, this portion, right? So I want where both f of x positive, checklist, g of x negative, checklist. Where? From where? From here, from this side, for all x values, from this side to that. The graph of f of x is gradient, is positive, is going up, but the graph of g is negative. It has got its graph below the x-axis. So my answer for this first portion here, is just basically x is going to be less than or equal to negative 2. So from all values of negative 2 to the left-hand side, the gradient of f of x is positive, is going uphill, but g of x is actually downhill. Or rather, g of x is actually below the x-axis, so it will be negative. So g of x is negative here, and then the gradient here of f of x is positive. So both of them are negative and positive from x is less than or equal to negative 2. That's fine. So I've answered the first one. Let me try this one here. What if the gradient of f of x is negative and at the same time which g of x is positive? From where to where? All right? So break this down. Look at this. If you were to come from here, from negative 2, and you end up here at 6, check this out. Notice that the gradient of f of x is decreasing. That's true. And so it means it's negative. And it even goes further than just this portion where I ended here. It goes further. Then g of x is positive throughout, because the graph of g of x goes up like this throughout. So if I notice from this portion and portion, the gradient is positive, gradient is negative rather, gradient of f of x is negative, so sorry about that, negative, and g of x is positive. Fine. And then here, the gradient is still negative, and g of x keeps on going up, g of x is positive. So from x is greater than 2, everything from x is greater than 2, what's happened to the graph of g is positive. What's up with the gradient of f is negative? How do I know? Gradient of f is going down, while g on the other side keeps on going up above the x-axis, it is positive. So your next answer should be x is greater than or equal to 2. I got 2 hands there. I want to attend to them right now. Okay, let's see who's who here. Lebogang, go ahead. Lebogang, I've unmuted you. Should be able to say something. I can hear you.
Hello, sir. Can you hear me?
Yeah.
Okay, so my question is, when you write your answers, when do you use and or? Like this answer that says x is less than or equal to -2, and then also x is in between -2 and 6. When do you use and or?
Like it, okay, the end part incorporates both answers. If both answers are -2 is less than or equal to x, for example, x is less than 6. That's the first answer. Then the other answer is x is less than -2, as an example. You say and. Because it means for whatever question you're given, those two portions are the same, right? And then or, again, similar, same thing. In the exam, if you check your memo, they write this and or. Either way, it doesn't make a difference. And even if you omit it, still it's fine. As long as they say, for example, answer is x is greater than 2, and the answer one says -2 is less than x, I'm just saying this, and right. Even if you leave it like this, the first answer is fine, the second answer is fine. They are not really technical about the English of and or. You can still write, say, x is greater than 2, and also -2 less than x less than 4 is still applicable, or you can say or you can leave it. Still, either way, it gets you to the same point. It's not much of a hassle. You will be okay as you go on along. So thank you so much for Lebogang for that one. That's fine. I think Percy has got their hand up as well. And Nelisa, I want to move on, guys, quickly, because I plan to do this in 20 minutes, because I've got lots of questions to do. Let's go, Percy.
Sir, I'm a bit confused as to how to find the derivative of a function. Is it always just a matter of getting the gradient of that function, or is there a way of doing it?
Okay, good. The derivative of a function is under the topic calculus. And so I haven't taught you that as yet. And also with the other guys, maybe that are not even taught where I teach, maybe you guys have been taught either way. But when you're trying to derive something, and you'll see this when I do a question using tangents right now. When you're trying to derive, all you're simply doing is you're finding the gradient of a certain point. In a typical graph, you would know that derivative stands for gradient. And when the gradient is positive, it's because you're going uphill. And when the gradient is negative, it's because, again, you're going downhill. So I will teach you how to be able to derive a function. You need to have an equation. It's under calculus. Derivatives are all under calculus. As soon as that comes through, whether you're being taught by me or whichever school you go to, that will be fine. It will be saved through. All right, I'm ready for the next one.
Sir.
Okay, good one, Percy. I think the next one is Nelisa. Go ahead, then we move on to our questions. Go ahead, Nelisa. I've unmuted you. Let me try this again. Go ahead. Nelisa, I've unmuted you. All right, maybe you come through again as soon as you can. Could be network issues or whatever the case could be. All right, I'm going on to my next question. This time, I'm going to the handout. The handout on page 22. I need to go to page 22 on the handout there. And I'm going to do this question that you're seeing. Let me know if you can see this question. Let me stop sharing and come back to the platform here. All right, there. Okay. I want to stop sharing and I'll come back to the platform. And then this. Okay, there you have it. I have 2017 IEB March paper 1, question 7. I'm going to highlight the question I want to do right here with you. This one here, and I'm just going to put a color onto it, just a bit of a color onto it there to make it stand out. Let me use maybe a different color, something brighter. There. 2017 IEB, please write down the page number. It's page 22, and I'm going to do this question. It's worth 6 marks. Let's work, family. Let's go. It says, given f of x is equal to negative 2x plus 2 over x plus 1, express f of x in the form f of x is equal to a over x plus p plus q, and hence write down the equations of the asymptotes. Okay? And hence write down the equations of the asymptotes. All right. Let me break it down. You're looking at an equation that probably looks a bit funny. I need you to understand that if you look at an equation, you must be able to tell just by looking at the equation whether dealing with a hyperbola, parabola, and exponential whatsoever. The equations themselves must let you know whether you're dealing with hyperbola, parabola, exponential, or whatsoever. So in this case, they want us to be able, right? I'm recording the session, guys. Don't worry. This thing will be posted to you guys. Don't worry. I got this. Session is being fine. We're going to get this thing done. Given f of x is equal to negative 2x plus 2 over x plus 1, they want you to write it in a parabola form. Because this format here, this whole format here, is definitely, hyperbola form. This format is definitely hyperbola. So the question is, how do I move from here, the one where it's negative 2, and then negative 2x plus 2 over x plus 1 into that? Let me show you how you do it. I'm going to move from this screen, and I'm going to go to the whiteboard screen so that at least you can be able to see what I'm going to do. If you don't understand, let me know again. I will be able to help you out as much as is possible. White screen, look at this. All right. I'm going to deal with the white screen there. There you are. There. Okay, should be able to see the white screen. What is my task? My task is to make sure that negative 2x plus 2 over x plus 1 is written in the format of a over x plus p plus q. So here's what you do. Now, there's about 2 ways of doing this, and I think this one is most understandable. You see, this x plus 1 at the bottom, so you write this like that. So you equate this format that you're given to the non-format. Now, in the non-format, the one that you know, at the bottom here, you've got x plus 1. Even write this one here, x plus 1. Write it like that, x plus 1. It's fine. So what's at the bottom on the left-hand side of the one that you're given, this one, and of the one that you're looking for, this one, write x plus 1. So whatever is the denominator from what you are given to what you're asked to become, x plus 1, x plus 1. Then let's do some math. Cross multiply both sides by x plus 1. There's a denominator on the left-hand side and another one on the right-hand side. Sharp. Cross multiply by x plus 1. In other words, I'll multiply this side by x plus 1. Multiply this by x plus 1. Multiply this also by x plus 1. So when I cross multiply this side, I want to get rid of the denominator. I'll end up having negative 2x plus 2. Because this x plus 1 here, and maybe the other x plus 1 that I would have put there, they definitely should cancel themselves off. So they cancel each other out there. Okay, that's fine. Okay, so I'll take that out there now. So you're multiplying both sides by x plus 1. Even when you multiply this guy by x plus 1, you end up with a. Multiply q by x plus 1. There you are. Okay, that math gets interesting. Remember, you're trying to find a q, and then this one here, you already know that it's a 1 because you took it from this side. Always do that. Then it's equal to a, all right, plus qx plus q. I'm opening up the brackets. Negative 2x plus 2. Now here's what the key is. If you look at the left-hand side, you start off with something with an x, negative 2x. Do the same thing on the right-hand side. Start off with something with an x. So a negative 2x here, then the plus 2. So here I've started off with qx. I've got negative 2x, okay? And then you have started off with qx. Then here you've got a and q plus a plus q. Leave it there. Okay, it means to me the following important thing. Since this side and this side are equal, then it means negative 2x goes with the guy on the other side with an x like this. So in other words, negative 2x becomes equal to qx. Listen to me, family. So first thing, what do? Let's go back. Let's go. I want to make sure that this marinates in your head. You're trying to convert this version of a hyperbola into this version that you know. That's what you're trying to do. Cross multiply both sides by x plus 1. Like I said, put the denominator as it is x plus 1. There, x plus 1. Cross multiply by it, get rid of it. I've cross multiplied this side by x plus 1. I'm left with this guy. By x plus 1, this guy. By x plus 1, that guy. Open the brackets for this one here. There you are. We're now here. Group the x's on their own. This one, I started off with an x. I will start off here also with an x. There's a positive 2 on this side. Then here, this will be a plus q. All right? Right. Someone raise their hand there. Well, there you are. I'm going to mute you. Go ahead. I've unmuted you, so I'm just waiting for you to say something. Okay, I don't know if there's network or something, but let me continue. So I was saying to you guys, key for me is being able to put them x first, there, the guys with the x, and then that. Then the plus 2, the 2, this one, goes with the rest of everything else, a plus q. So 2 becomes equal to a plus q. You're looking for q for a as it is. Now let's start here. Start here. The x is divided by x, so you're left with negative 2 is equal to q. Found my first answer. So q is called negative 2. Then I come here and say, okay, 2 from here will be equal to a, which I don't know, plus q, which I found as negative 2. That means on the other side, a becomes equal to a positive 4. That's what I get. So then I can write down my equation in the format that I know. A, what is a? A positive 4. Then over x plus 1 as it was in the previous one. Then plus q. My q in this case is negative 2. Negative 2. And the question it says to me, write down the asymptotes. The equation of the asymptotes. Since this is a hyperbola, we know the version to be a over x minus p. Sometimes they say plus q plus p, which is still the same thing. You just need to know how to reverse the signs. Plus q. I prefer this version is straightforward. So therefore, my x asymptote, this one, becomes equal to negative 1. And my y asymptote, which is q, becomes equal to negative 2. And that's how you get the 6 marks. So in the exam, if you're given in this version, and you're asked to make it into this version, equate them. Whatever is at the bottom, go with it, move with it, cross multiply by x plus 1. Get rid of the x plus 1. Then make sure that our x on the left-hand side, they are with the other x on the right-hand side, equate them together. Then whatever remains, that's plus 2, and the other side, a plus q, make sure that they're equal to each other, and that's how you get your answer from there on. So therefore, this becomes the equation that is seen there. F of x is equal to 4 over x plus 1 and all that. Okay, Ashoko, you lifted up your hand and I'd like to attend to you.
Sir, can you hear me? Sir, can you hear me?
Yes, sir.
Can you please explain from negative 2x is equals to q times x? Because I can't see the other side. of the equations.
Okay, you can't see the other side of the screen. Okay, fine.
Yes, sir.
Okay, let me let people. Okay, let me explain. Fine. Let me explain on that. So you're asking me to come from this part. Let me take this out, this portion out. Maybe you can see from there. All right. Work with me. You want me to come from negative 2x plus 2. Don't mute yourself yet, because I need to hear what you want, what you're saying I should do. Are you saying I should start here?
No, sir. Cancel.
Okay.
Okay, cancel plus A plus Q.
Like from here, A plus Q, and then this 2 here. I'm not so sure I'm giving the right feel to the question itself. But let me, be that what it is, let me explain. So all I'm saying is gather up your x's, right? And make sure that if you start with an x on the left-hand side, do the same on the right-hand side. So it gets me to negative 2x is equal to qx. Then cancel off the x's. That means ultimately q is equal to negative 2. You're left on this side here with a positive 2. It goes with the other side, a plus q, that's 2, is a plus q. But I know q. Q is negative 2. To the other side, that gets me a is 4. That's why confidently I could say a is 4, q negative 2, and then p in this case will be negative 1, and then they correspond to my particular asymptotes, like what you see there. Okay, I'm hoping I'm answering that. I'll try to explain from.
Thank you, sir. Yeah.
Right. Again, I think also as well, then try to move the screen if you can't see the box, right? That if you can't see the screen that I have, so try to move your phone. You should be able to see it because I'm writing on the left-hand side of the screen as well as the right-hand side. You should be able to see everything cleared up. Guys, let's move on. Page 21. We're going to my handout. Siamtanda, you got your hand up. Let's go. I'm unmuting you. Oh yeah.
Sir, can I ask?
Yeah.
Am I wrong if ngithatha u positive 2 ngimiyenze u-q then abe negative and change the sign, then I times negative 2 with negative 2?
Okay, so you're saying, are you right if you take the positive 2 and go with who?
Abe u-q you change the sign.
This is q after getting it from here, right? Right, yes.
Then ngithathe u-negative 2 loga 2x times in the negative 2 so uzonginika 4.
No. Okay, I hear where you're coming from. Okay, no. Let me explain this. When I do the next video, right? The next video on nature of roots, I will show you how you actually can come up from there. What you're simply saying, or what should be done, is exactly what I've just written there on the board. You go with coefficients to say this is the negative 2, and this is the negative 2x rather. There's a qx. These guys with the x's, let the x together. Then the plus 2 here goes with the rest that's remaining. That's exactly what you should do. It's the right way to do. The other option is to use plus and minus situations, which I don't want you guys to learn. Rather, I want you guys to be able to understand this method here, because when I teach you in nature of roots, it becomes a bit understandable when I'm doing it from this perspective.
Okay,
right?
thank you.
Rather do it that way, it becomes a bit easier for you. Okay, page 21, guys. I'm going to stop sharing the screen here and go to page 21 of the handout. There we are, page 21 of the handout. There's a question that I want there. It's the 2016 overbag question. Page 21 of the handout, 2016 overbag, the one that you're looking at right there. I'm ready. I'm ready for this one. We're going to do it together. It says the sketch shows f of x is equal to all of that, and g of x is equal to all of that. So you are given the equations, not really in numbers, just ax squared bx and c, g of x mx plus c. So just by looking at the format that they gave you, f of x should be a parabola and g of x should be a straight line. That's fine. Turning point of the parabola is 1 and -8. Both f and g pass through the point 0 and 6. Let me look at the diagram. So I look at the fact that F and G, they intersect. Let me just show you from there. F and G, they intersect at 0 and -6, which is this portion here, as well as here, there. I don't know the x-coordinate here. I'm clueless. I don't know. I just know the coordinates here. I don't. What I do know about this part, though, is that the y-coordinate is 0. So the intersection of the graph of F and G, the straight line and the quadratic, the intersection, one of them is at the y-intercept, the other one is at the x-intercept. Fine. There's a turning point, 1 and 8. There's a turning point, point 1 and 8. That's fine. I need you to know this when dealing with the quadratic. The turning point, the x-coordinate of the turning point is actually also known as the line of symmetry. So in other words, the graph of F, which is the quadratic, is cut in the middle when x is equal to 1. So this portion and that portion are equal when x is equal to 1. So the x-coordinate of the turning point is also the axis of symmetry. So the turning point is 1 and 8. Fine. PQ. Let's discuss before we go further. PQ. Now, P and Q are on the same straight line. Fine. The x-coordinate of P, okay, and the x-coordinate of Q, okay, x-coordinate of P, x-coordinate of Q, they're just the same. Because they're on the same straight line. So if I were to go down here, and pick an x-coordinate, let me say it's 2 or 3 maybe, just 3, fine. Then the x-coordinate of Q will be 3. The x-coordinate of P would also be 3. They're on the same straight line. What's different are the y-coordinates. The y-coordinate of P, I don't know it. The y-coordinate of Q, I also don't know it. Interesting enough, P is on f of x. Q is on g of x. So that's how we look at this diagram. Then we start doing questions together and seeing how far we go. All right, let's go. Let's do questions. It says show that A is equal to -2, B is equal to 4, and C is equal to 6. So they want me to show that as can be seen. As on me, let's work. Now, what are you given? The given turning points. The quadratic formula or the quadratic equation or the quadratic graph can be written in a turning point format like this. It can be written in a turning point format like this. Very true. Right, where P is the x-coordinate of the turning point, 1, and Q is the y-coordinate of the turning point, 8. So I can put what I know. So it means y is equal to A, which I don't know yet, x minus 1 squared, because P is 1, the x-coordinate of your particular turning point, and Q is a positive 8, as can be seen. So that's what I have. Judging by the shape of the graph, I can tell you that the graph there is a sad graph. That means A is negative. Now, how do I find the A? It's quite easy. So here's your situation you are here. To find A, you just need to substitute a random point on the graph. Any point on the graph that you can see, that other than the turning point, is this point here, 0 and 6. So when y is equal to 6 there, x is equal to 0. We do the math together and see how far we can go. We go math. A, 0 minus 1 is 1, is -1. -1 squared is 1. That's you have, plus 8, and then that's 6. So 6 becomes equal to A plus 8. Obviously, A becomes equal to -2. I found my A, -2. But I need to make sure that I show them that A is -2 and the B is what they gave us and the C is what they gave us. So far, what is my equation looking like? It's like this. Check this out. It's basically -2 x minus 1 squared plus 8. That's how it looks like so far. For me to make it into this format and identify A and B and C, to make it into that format, I need to open up the brackets. That's all. So I'm going to go -2. First of all, open up this, guys, because they're in the brackets. It's squared. So it becomes now, I'm opening up x squared, then it becomes -2x, right? I'm doing the shortcut version, plus 1, then plus 8. Open up the brackets now, -2 multiplies, -2x squared, we go, +4x, we go, -2, then plus 8. We do the math, -2x squared, then we go plus 4x, okay, then plus 6. Ultimately, A becomes -2, B becomes a +4, and C on the other flip side becomes a 6. And that's how they wanted you to prove it. So you're using the turning point variation, what you know, what you have, to be able to find what you don't know. I want you to write this down. If you have any question on it, raise up your hand, should be able to help you out. Okay, write this down quickly. Then we move on to the next one. Okay, I'm taking this out in the next 10 seconds or so. And all. All right, taking this out, it's gone. So you're using the turning point formula in a situation whereby it's the turning points that you're given. Let's go to our next question. It says to me, determine the equation of g of x, and that's 5 marks. Okay, let's work. Determine the equation of g of x, and that's 5 marks. Now, g of x is a straight line. To find the equation of a straight line, you need 2 things. You need 2 points on that straight line so that it can give you the gradient. So number 1, I need gradient. How do I get the gradient between 2 points? How do I get the gradient? I need 2 points. If I look at the graph of G, I have 1 point, 0 and 6, okay? Fine, let's keep it there, not a problem. And then notice that one of the points that is on the graph of G is also on the graph of F. It's this point here. We use a different color pen. Like, it's this point. If I'm able to find this point, then I can use this point and that point on the straight line to find the gradient. And then after that, I should be able to find the equation of a straight line. So my issue now is finding this coordinate here, so that I have this coordinate and then that coordinate, find the gradient, then find the equation of a straight line. Because to find the equation of a straight line, I need the gradient and also at least 1 point on the graph, and that's fine. Sure. So let's find this point here, which happens to be the x-intercept. Now, I don't have the equation of the straight line. That's what I'm looking for. But I do have the equation of the parabola, which you guys now know as y is equal to -2x squared plus 4x plus 6, and that's fine. If I'm able to find the x value here when y is 0, then I can use that point to be able to find the equation of the straight line. So all I need to do is say y is 0. At this point, y even here, y is 0. I'm going to take 2 answers for x anyway. Y is 0. So I'm going to do the math. Divide everything by -2 to make your life easy. This becomes x squared minus 2x minus 3. Then you can factorize nicely from there on. I got an x there, and I got an x right there. So when I'm factorizing here, I should be able to get a -3 and a +1 when I'm factorizing. So it means x is equal to a 3 or x is equal to a -1. So if I look at the values given, This point here is on the positive x-axis. So x here should be 3, while y is 0. On the other flip side of the coin, x here should be -1, and on the other side, y should be 0. So I have this one and that one. So I've just killed 2 birds with 1 stone. But that was never my intention. My intention was never to find both x-intercepts. I just needed one of them, but I needed to do this to find that one. So now I have a point on the straight line, and I can find the gradient. So I've got a point 0.06, the one that I had, and then I've got another point 0.30, as can be seen. I find the gradient. The formula says y2 minus y1. Let's call this y2. 6 minus y1, 0. There you are. Over x2, this one, 0 minus 3. So the answer becomes 6 divided by -3, which is -2. And the equation of a straight line is always mx plus c. M is your gradient, -2x. C is always your y-intercept, which in this case is +6. So your answer for the equation of g of x is that. And that becomes your answer right there. So you write that one down. So I needed to get ex coordinate or the x-intercept so that it can be a point on that straight line, do the wall gradient situation. Then from there on, I'm able to find the equation of the straight line. Tebogo, you raised your hand. Go ahead.
Good afternoon, sir.
Afternoon, how you doing?
I'm finding you, sir. Sir, by 4.1, so I just wanted to ask if you can, is it fine if we use f prime of x to find b, then you use that to find c, the turning point equation?
So you're saying on 4.1, just let me just take this out and go to 4.1. There. You're saying don't mute yourself. 4.1.
Okay, sir.
Do what?
You use f prime of x to find b, sir.
Oh yes, that's fine. I hear where you're coming from. Yeah, that's fine. You can do that. F prime of x. That's another way of doing it. Okay, so that's fine. I think it's not really long. It can be a bit tedious, but it's not long, right? So I will help you to be able to. It's not long. It's okay. You can do that. That's another version of all of this, right? Let me go to 4.3, and then I'll do 4.3, and then maybe go to 4.4 and all that. Let's see how far we're going on this one. 4.3 says determine. Okay, let me just stop sharing quickly here. I want to see something. All right, 4.3. Okay, let me just close to this. Honestly, my lighting sun is messing up with me here. All right. I don't want to stop the videos, guys. I just want to make sure that there's no videos at all times. Your profile pictures are fine. That's okay. So that at least you can be able to see. We can be able to concentrate on one person throughout the whole thing. Okay. Now, I'm going to go to this question. It talks about a tangent. Now, before I go to tangent, I want to explain it. And listen to me. It applies in this topic that we're having right now. It also applies in cubic graphs, especially in cubic graphs. Very important that you understand. So here's what you need to learn about the tangent. A tangent is a straight line. That's what it is. A tangent is a straight line. But what about it? It's a straight line that passes through a point on a graph. So this is the graph of f of x, okay? And this one is the graph of g of x, okay? G of x happens to be passing through this point on f of x. It looks like the point where, this point here, the graph of f and g, they meet. Right at that point, they meet. It's called a point of contact. I'm just going to abbreviate it. Point of contact. Fine. Now, you need to understand a relationship between the tangent and the f of x, because tangent is the straight line. So this one is the tangent. Now, the most important relationship is this. The gradient of f of x, which you write it like f prime x. The gradient of f of x and the gradient of the tangent at the point of contact, only at the point of contact, these two gradients are the same. The gradient of f of x, the gradient of the tangent where? At the point of contact. What about them? They're equal. Very important. Number two, the coordinates of the point of contact. Okay, I gotta break this down. So let's say it's x here, and let's say it's y there. The coordinates of the point of contact, x and y, they are true. They are applicable to the equation of f of x, also applicable to the equation of g of x. In other words, this coordinate, x and y, this point of contact can be true for the equation of f of x and also can be true for the equation of g of x. So the two most important things about a tangent is that the gradient of the tangent and the gradient of f of x, they are equal. And gradient of f of x is f prime x. They are only equal at the point of contact. Number two, the point of contact is applicable for f of x and also applicable for g of x. That's what I need you to know as we start to do that question. Okay, fine. Let's play around with this and see how far we can go. Okay, let's play around with this. I'm sharing the screen now. Let me make sure that you guys can see what's on the screen. Right, there you are. I'm good to go. It says to me here, determine the coordinates of the point of contact of the tangent to f of x that is parallel to g of x. Determine the points of contact of the tangent to f of x, and that tangent to f of x happens to be parallel to g of x. Let me say that again. You are looking for the point of contact where? Between f of x and g of x, where what is happening? Where the tangent of f of x is parallel to g of x. Fine. Let me help you. So let's say the tangent, because once I say it's parallel, I need to get this to understand this. So I'm learning that the tangent happens to be parallel to g of x. And when you guys do analytical geometry, you will know that when two straight lines are parallel, it means their gradients are equal. In other words here, the gradient of the tangent should be equal to the gradient of the straight line g of x. So the gradient of the tangent should be equal to the gradient of g of x, the straight line. And we know the gradient of the straight line because the equation of the straight line is this one, like this. And we can tell just from the equation that the gradient of the straight line, this one, g of x, and the gradient of that tangent, they are equal because those lines are parallel. Fine. So I have found the gradient of the tangent. But from what I was teaching you guys, I say to you, the derivative of f of x should be equal to the gradient of the tangent. That's what I said. And f of x happens to be negative 2x squared plus 4x plus 6. So the derivative of this guy should be equal to the gradient of the tangent, which is negative 2. So let me derive f of x. And to derive is pretty easy. Here's the song. So to derive, you say power, which is 2, multiplies coefficient, which is negative 2. So it's going to be 2 times negative 2. That gives you negative 4. Then you say power minus 1. You'll do this in calculus quite a lot. So it's power multiplies coefficient, power minus 1. I'm deriving. So I get this as negative 4x. And then I'm going to come here again, I'm going to derive. The power is 1 here. Power multiplies coefficient, that's plus 4. Power, which is 1, minus 1. 1 minus 1 is 0, x to the power 0 is 1. So the answer becomes 4. When you derive a number, according to the laws of in calculus, the answer is always 0. So the derivative of f of x is this. Again, guys, we'll do this a lot when you do calculus. Power multiplies coefficient, power minus 1. So the derivative of f of x, I have it. Which one is it? That. This derivative happens to be equal to the gradient of the tangent, -2. How was I able to know the gradient of the tangent? Because they told me that the tangent and g of x are parallel, and I'm learning that two parallel lines have equal gradients, and I'm looking for the point of contact. That's what I'm looking for. We do the math here. Sharp, we go. So it becomes -4x is equal to -2, and then here I've got -4. So it becomes -4x is equal to a -6. Then divide both sides by -4, -6 divided by -4. That becomes ultimately a 3/2. So the x value of the point of contact is 3/2. That's okay. X value of the point of contact is 3/2. Me, now I say to you, remember that the point of contact is applicable in f of x, where there is the tangent, and also in g of x, and also in the tangent itself, where there is the graph, the curve. That point x is equal to 3/2 lies on the curve, the graph of f of x, and also that point lies on the tangent. So if I know the equation of f of x, and I know that the point of contact has x as 3/2, then I can find the y-coordinate of the point of contact, because I can substitute the value for x is equal to 3/2 into the equation of f of x, because that's the only one that I have. I don't have the equation of the tangent. I don't. I only have the equation of f of x. So I'm going to take the point of contact, the x value of the point of contact, and substitute it into the equation of f of x, because the point of contact is found on the tangent, is found on the curve as well, or on the quadratic graph, is found there. Sharp. Let's break it down together. So I need you guys to help me out. I don't have my calculator with me here. I need you to help me out. So I'm going to substitute x as 3/2. So it's now going to be, I'm going to do the original equation, because that's the only one that I have. So it's going to be -2, and then here 3/2 squared, then plus 4, then 3/2, then plus 6 equal to, I'm waiting for an answer from the group there. You guys will type the answer. I want to see what the answer is. Talk to me. You just type it there, put your calculator through, and you'll be okay. Just type it for me. As soon as the message pops up there, just try. Maybe it's 15/2. I don't know. I don't remember that. But try that. Okay, let me go back and share the screen, just in case maybe you're not seeing it. What answer did you get? So exactly 15/2. That's the answer that the people got there. That's 15/2. And that's okay by me, 15/2. Let me just go back to the question and write everything down quickly again so that everyone can understand. 15/2. So here's what you, thank you so much. I see the answers. So the first thing was to notice that the gradient of the tangent is equal to gradient of g of x, because they are parallel to each other, and therefore the gradient of the tangent becomes equal to -2. Second up was to recognize that you're given f of x, and because it's a tangent, then it means the derivative of f of x will be equal to the gradient of the tangent. When we derive power multiplies coefficient, power minus 1. So my derivative again should be equal to -4x plus 4. This derivative of f of x should equate itself to the tangent. That's the rule. So it's -4x plus 4 is equal to -2. We do the math. I'm just going to be quick on this because I've already done this. X is equal to 3/2. Then you guys say to me, now that we're looking for the y value when x is 3/2, I'm going to say f of 3/2. -2 3 over 2 squared, you guys found it as 7.5, or 15 over 2. I agree with you. 3 over 2 plus 6, my answer becomes 15 over 2. So the point of contact happens when x is 3 over 2 and y is 15 over 2. Thank you. Let's move on to the next one. Very quickly. All right, family. I'm going to my next one. Let me take this out. Right, next one quickly, then we can see if we can try something more interesting than what we're doing now, something a bit more, in there. All right. Guys have been great so far and amazing. We'll make sure that I'll try my best to help you out in all aspects and all. Like I said, this thing, I will post it. I'll send it on the WhatsApp groups. The link to the YouTube channel. I've also uploaded some stuff on that YouTube channel. I just needed some verification from Google, but they say it's going to take 24 hours. So that's why I'm live streaming on Facebook as well. I'll also send you all the links for Facebook so you can just watch these things, rewind, upload, download, or whatever you want. Sharp, let's go to the next one, please. Here's the next one. Says to me, if PQ is a line parallel to the y-axis, with P on F and Q on G, determine the length of PQ in terms of X. Right. Let me go to the screen, the whiteboard screen, and I'll help you. Right. Eyes on the screen. They're saying to you or to us here, and this is a very important thing. Just going to try and draw this. Let me just do this. This is P and this is Q. Now, earlier on I said the x coordinate of P and the one for Q, they're the same. That's what I said. The y coordinates are different. That's very true. And the question is saying, write down the length of PQ in terms of x. Now, P happens to be lying on the graph of f of x, whose equation we know is negative 2x squared plus 4x and then plus 6. Then g of x on the other side, we know the equation is also negative 2x and then also plus 6, I think, if I'm not mistaken. So I know the equation of f of x, I know the equation of g of x, I know them. Now, when you write a coordinate in maths, you write it as x and y, that's okay. But did you know that that y can also be written as f of x or g of x or h of x, whatever they gave you? Because this is the x coordinate and this is the y coordinate. So when you look at the point P, the point P has the x coordinate being x and the y coordinate being f of x. And the point Q has the x coordinate being x just like for P, but its y coordinate, the y coordinate of Q, is g of x. And the question says, write down the distance from P to Q in terms of x. Now in math, when you've got the same x values there, and you're looking for the distance between the 2 points of P and Q, it's always the y values at the top, the big y value at the top for f of x minus the small y value at the bottom, g of x. Let me translate what I've just said. I'm saying to you, when you're looking for the distance PQ, it's always top graph, f of x, minus bottom graph, g of x, because they're on the same straight line. Top graph, f of x, bottom graph, g of x. That's how you find the distance. So in other words, you have a situation like f of x minus g of x. But I know f of x, is negative 2x squared plus 4x plus 6 minus, because it's always top graph minus bottom graph minus g of x. What is g of x? Negative 2x plus 6. We do the math. Negative 2x squared plus 4x plus 6, open up, plus 2x, all right, minus 6. The math is easy. Negative 2x squared, okay, plus 6x plus 6x, no, that one cancel out, gives you 0. Thank you for that. So then at this one here, in terms of x, PQ is just top graph minus bottom graph, f of x minus g of x. That's your PQ at the end of the day. In terms of x, then I love this one. If we had done calculus, then I would have shown you that usually the next question that they say calculate the maximum length of PQ. Maximum length, that's application to calculus, derive and equate to 0. So you need to know maybe this thing. Whenever you got a straight line, right, and one of the points is on a top graph, the other point is on a bottom graph, then the distance between them will be top graph f of x equation minus bottom graph g of x equation. Because the x values are the same, but the f of x and g of x values are the ones that are different. Write this down quickly, and I'm going to take it out now. Right, very important that you understand the concept of f of x and g of x. Okay, top graph minus bottom graph, I'm taking this out. Right, let me know if you joined the game. Let me just put it back just in case someone is still writing this, just 5 more seconds. Let me know again, guys, if you understand, don't be shy to ask a question. Just lift up your hand, I'll help you guys. You should be able. Then you have your hand up. There, I am unmuting you. There. I've unmuted you.
Hi, sir. Hi.
Good, I can hear you. Go ahead.
Well, what if they wanted the value of the distance PQ? Do we then equate the two graphs?
So they want the value PQ.
Yes.
Usually, if they want, they give you the coordinates. So they'll probably give you the coordinates, or you can find them. So let's say it was 3 and 7, and then also Q here. Let's say it's 3 and 2. So then it means the distance, since the x values are the same, will be top graph, big number, the y value, 7, minus bottom graph, 2. So it's 7 minus 2, which is just 5 units. So it's just going to be top minus bottom, as you can see. So it's just going to give you 5 units on that one. All right. So that's basically what you have. They'll give you the coordinates, or you can find them for yourself. Then simple do top 7 minus 2. Or you can say big number minus small number. As long as the x values are the same. Big number minus small number. When we do analytical geometry, you can use the equation of
Speak on your name.
How do you say this? I can't did you say? I love think it's nice to think so. That's all. It's so data, data. Me. It made me. Oh, I slept me. Yo, yabo. Hindi ka na. And everyone is going, oh, people do that. Yeah.
Okay, guys, listen up. I think I had some ESCOM issue here and it messed up everything. All right. Okay, hold on. I'm just going to correct this quickly. Sorry about that glitch of things. I'm still here. Okay. I'm now live streaming using my phone. Get everyone in and make myself visible. Pin my video here. Right. Okay, now I need to deactivate my video now so that at least the bandwidth can be fine. So let me deactivate my video. You can be able to see me though. Okay, there you are. You'll be able to see me and that's fine. Rather hear me though, not even see me. Sorry about that, guys. It was a mistake. They think ESCOM happened. Welcome to South Africa. Okay, allow me to use my phone. Let me just deactivate a couple of things so that it doesn't ring and mess up everything. You guys were busy with the other question, I think. F of x dot g of x less than 0. That's where we're at. Let's do it together quickly and see if we're gonna get to the right track. F of x dot g of x. Hold on, guys. Hold on, family. Hold on. I'm gonna transfer something here. This glitch of network is messed me up. Okay, I'm back. Zandile, you raised your hand. I want to attend to you, Zandile. Go ahead. I'm unmuting you. Zandile, I've asked to unmute you. Talk to me.
So I'm not sure who asked the question where she said that what if they ask you for the actual unit of PQ without giving you the coordinates, right?
Without giving you the coordinates.
Yeah, of P and Q. So they just give you like one, like the X coordinate, and they don't give you the Y of both P and Q. In IEB paper 1, November of 2017, the question 7 there does ask you.
Okay, good question. Let me answer that. Thank you so much, Angela, for that. Okay. So if you're given the X value of Q and P, right, or just the X value of Q is fine. Obviously, you would know that the X value of Q and the one for P will be the same. You have the equation of P, right, which is f of X is equal to negative 2x squared plus 4x and then plus 6. So since you know the value of x here, let's say x is 1 for q as an example, right? That means also for p is going to be 1. Then you just substitute into the equation where p is found to get your y value. So you're going to put the 1 there to get the y value there. Same thing that you're going to do for q. You have the equation for q, get the y value. Then once you get those y values, it's top number minus bottom number, and you get your answer from there. Top minus bottom, get your answer from there. Thank you for that one, Zandile. I'm hoping I answered you properly on that. Okay, let's keep going. We were doing this one here, f of x dot g of x is less than 0. That's the one that we're dealing with. Okay, as I said in the beginning, f of x dot g of x less than 0, it means you're looking for parts of the graph where it's going to be positive and negative or negative and positive. So less than 0. So I'm looking for parts of the graph where f is positive and g is negative, or f is negative and g is positive. All right, let's break it down together and see if we're on the right track with this. Now, when f is positive, you're talking about above the x-axis. And when g is negative, it's below. So you're looking for parts of the graph where f can be above the x-axis, but g is below. So let's see. Let's talk about all positive for f. Positive f, I'll use the black color here. So that's positive f everywhere. F is positive, is above the x-axis. Then g is positive, I'll use red. Above the x-axis, g is positive, above x-axis there. Then f is negative, where I'll use the blue one here. Where else? There. G is negative, where? Here. There. So those are the parts. The black part, that's positive parts of f. The red part, that's positive parts of g. The green part is negative parts of g below the x-axis. The blue part is negative parts of f. Question says, find values of x where f of x will be positive, but at the same time, g of x being negative. Let's see. F of x is positive, they are. So when f is positive, it's from here to this portion there. That's where f is positive, right? And is there a part when f is positive that g is negative? I don't think so. It's not there. Because the moment when f is positive, from negative, because I know this point, I think this point was -1, if I'm not mistaken, -1 and 0. And this point here should have been 3 and 0, right? If for me, if f is positive between -1 and 3, that whole portion, which is also positive. So I don't have an answer for this part. This part I don't have an answer. Let me try the second part. F is negative, but g is positive. Now, if I come after 3, then both of them are negative, so can't work. If I come before -1, this side, right? I notice that the graph of g, it can go straight like this, is positive, but the graph of f is negative, from -1, this side. So this one works for me. So the answer would be x is less than -1. So from -1 to the left-hand side, it means that your graph of f will be negative, but g will be positive. So that's your answer right there. You only have one answer for this circumstance or for this scenario. So that's what you have. Please write it down. That's your answer, as can be seen. Okay. Then I'm going to my next one. Let's take this out. Let's take this out. There you are. Okay. Let's try the last one there. Then I'm going to try and give you guys a question very quickly to try on your own to see if you're on the right track. F of x is greater than or equal to g of x. That's 4.5. F of x, Makoma, there you are. You raised your hand. I'm just going to unmute you. Go ahead.
So you see with 4.5, right? When you do it with the way that I asked, with the x is an element of real numbers and what, do you include the -1 as in a box bracket or exclude it?
You should exclude it because they didn't say greater than, they didn't say less than or equal to, there was no equal sign. So you exclude it. So it's not from -1 to the left-hand side. It's actually you don't include -1. So you can't say from -1 because once you do that, it's like you are including -1, but it's after negative, or rather it's before -1. All numbers before -1, they accommodate that situation that you're given.
So it'll just
You
be a
okay with
normal
that?
round bracket.
Yeah, just a normal round bracket, right?
Okay.
Then I'm going, thank you so much. I'm going to my next one there. F of x is greater than or equal to g of x. Like I said in the beginning, we're looking for parts of the graph where it's above g of x. So f of x must be above g of x. F of x must be above g of x. Let me see. I'm going to use a different color to make sure that it stands out. F of x, there's my f of x. Where are you above g of x? From here, f of x, you're above. You're on top of g of x from there. I agree. Up to here, definitely. So from x is 0, because there x is 0, and then up to this portion here, when x is 3. So in other words, 0 is less than x, but x is less than 3. At that portion, the graph of f happens to be above the graph of g. Beautiful. Write that one down, guys. That becomes us. Anyone with a question on that? Still not understanding? I got your back. I'll help you to understand this. Still not understanding? Lusanda, Lunka, you have a question. Let me hear what you have to say.
Hi, can you hear me?
I can hear you.
Okay, hello. So for the previous question, don't you then include it? Because they said greater than or equals to. So for the values is x is greater than or equals to 0 and less than equals to 3.
Oh, okay. I didn't notice that it was a greater than or equal to. I didn't know it was an equal to sign. I actually wrote it in my head. I wrote it like this. Without the negative, without the equal to. So yes, there's going to be 0 is less than or equal to. Thank you for that correction. And then 3 as can be said. Now that's fine. You can write that one down that way. Maybe just exclusively for everyone. Whenever there's an equal to, right? Just include it. All the time, there's an equal to, just basically include it in everything that you're going to do. Okay, let me give you a question you can try on your own. Maybe before that question, you still have raised your hand. Let me just unmute you. Go ahead.
Oh yes, sorry, I forgot to ask, and I mean, this is a question we did a while ago, but when we were doing the whole tangent equations thing, you said that the gradients of the derivative and the gradients of the tangents are equal at that point of contact, right? And
Yes.
you said that how did you phrase it? The coordinates are true, meaning that, yeah, I don't even know what that means, but the coordinates are true. But I assumed it means that because when we were calculating, when we equated the derivative to the gradient being, what was the gradient kind of? -2, right?
It was -2. It was -2.
We got that x is equals to 3/2. So then that x was substituted into the original formula of f of x. Does that not mean that you can also substitute? Pardon?
Yeah, you're right.
Does that not mean then you can also substitute it into g of x? Because then I don't know, like I feel like I'm confused there. Like, yeah.
Okay, good one. Let me just explain that. The point of contact that we got was 3/2 and 15/2.
Okay.
When I say that point of contact is true for both f of x and the tangent, it simply means to me that when I take 3/2 into the equation of f of x, I should get y is 15/2. Same thing if I take 3/2 into the equation of the tangent, then I must get y as 15/2. But I think you're confusing this with this. Notice that g of x in that question was not the tangent.
Oh, yes.
It wasn't.
Thank
G of x
you.
was a line cutting
That it
through
was
the graph.
parallel to.
The tangent happened to be parallel to the g of x.
Okay, that was the problem. Okay, thank you.
Cool. That's fine. Right. Somebody says they want me to repeat 4.6, not a problem. Let me go back to 4.6 on that one, and I will explain this quickly. Then we can go to page 19. That's the question that I want us to do as we glide towards the end of our lesson. Here, your time flies. Follow my lead. It says f of x again. I'm going to explain this is greater than g of x. Let me translate this to English, greater than or equal to. When I translate this to English, I'm simply saying to myself, I'm looking for parts of the graph of f where it's on top, where it's bigger on top of the graph of g, greater than the graph of g. Where? Here. Can you see it's on top? It's greater. The graph of f is greater than the graph of g, like what you're looking at right there. So at the end of the day, from where to where? From this portion here, whereby it is here for x is 0, this straight line here, right, to x is 3, that other line there. So this portion right here, from x is 0 up to x is 3, the graph of f is above the graph of g. So 0 is less than or equal to x, x is less than or equal to 3, and that's your answer for that one. Okay, thank you so much. Let's go to page 19. Page 19 on that one. On page 19, I want the last question on page 19 actually, right? Page 19, I want the last one. It's this one. It's 2014 standard grade. I want to mark it there. I'm going to try and make sure that I do this one quickly. 2014 standard grade. Let me take this out. Yeah, I'm going to annotate it there. I start. The diagram below, not drawn to scale, represents the graphs of f, the graphs of a parabola, f, which casts the y-axis at -2, passes through points p, -1 and 1, and q, 2 and -2. So that's what you have. Then it says also as well, a straight line, G, passes through Q and R, a hyperbola. Now, I love this one. It says a hyperbola where h of x is less than 0, that passes through point P. Now, look at the diagram. Someone would think that this graph is exponential. It's not. It's actually a parabola. H is a parabola. It's just that your parabola has its h of x is less than 0. So it's one-sided. There's no other side to it. It's just one-sided. And I'll teach you how to do this when a parabola is one-sided. But let's go to the question. Show that the equation of the parabola is this. Show that the equation of parabola is that, and that's 6 marks for you. Okay. Let's get down to understand what's going on. Now, I have a problem here. On the parabola, I have 3 coordinates. I have 3 of them. I have Q, which I know. I have this one, which I also know, which will be negative, which will be 0 and -2. I have this one, which I also know. Then I have R, which I don't know. Okay, no problem. The equation of a parabola is always y, that's the standard form, ax squared plus bx plus c. The c is always your y-intercept. So in this case, the c will be -2, because I'm looking for, I want to show that the equation is like this. So the c will be -2 just by knowing the fact that c is the y-intercept. I can pick it as -2. So currently my graph looks like this, or my equation looks like this. Okay, so I need to write down what I know. C is the y-intercept always, -2. So my equation looks like y is equal to ax squared plus bx minus 2. That's my c. Okay, sharp. I don't know A and B, I don't. But I can tell you that I see that there's a coordinate 2 and -2 on the graph of F. There's also another coordinate -1 and 1 on the graph of F. So it means this coordinate of Q is substitutable in this equation. In other words, I'm expecting that when y is -2, x will be 2. So let's have it like that. And then there, x is 2, and then minus 2. That becomes 4a plus 2b minus 2 minus 2. And then I can take the minus 2 to the other side, 0 is equal to 4a plus 2b. Now, this is, I can't find a and b like this. I need another equation. So let me call this equation, and I'm going to do this simultaneously anyway. Because I've substituted this first point there, I need to substitute another point there. So let me go. When x is negative 1, y is equal to a positive 1. So let me come back to this. So I'm going to say 1 is equal to a, which I don't know, but x is, okay, negative 1 rather. Yeah, it's 1 rather. It's 1. X is 1. No, y is 1. Then x is negative 1. Negative 1 for x squared. And then plus b. And then negative 1 for x minus 2. We go further. Negative 1 squared is 1. 1 times a is a minus b on the other side, 1. Then plus negative 2 there. Then I can take it to the other side. It should be able to give me a 3. If I take it to the other side, then that's a minus b. I can choose to make a the subject of the formula, and that becomes equation number 2. And now we can solve them simultaneously. Let's see if we're doing the right thing, if we're on the right track. Fine. So I've got equation 1 and equation 2, and I want to solve them simultaneously. So I'm going to say equation 2 into equation 1. In other words, I'm expecting that 0 is equal to 4, what's a is 3 plus b, then plus 2b, which should give me a 12 plus 4b plus 2b, that's 0. Take 12 to the other side, negative 12, that's 6b, divide by 6, b becomes equal to negative 2. And if I look at my equation there, negative 2, coefficient of x, so I'm still on the right track. Let's find a. I can use equation 2 to find a. That becomes 3 plus b, but b is negative 2, is equal to a, so a is equal to 1. So then if I want to now substitute from here, I'll say y is equal to ax squared, a1, ax squared, plus b is negative 2, negative 2x, and then also plus c is negative 2. So nicely put, it's x squared minus 2x minus 2, just like what they wanted me to show them. So that's your answer for that one. Let me know if you understand this to catch you back. I'll help you. This will be our last question, by the way. Then the rest, you guys can try them on your own. The memo was sent to you, and that's fine. Okay. Right. Okay. Lebohang says, please go through it, say again. Africa raised their hand. So there, Africa, I want you to say something. Lebohang, I hear what you're saying.
Sir.
Yes.
Can you hear me? So when it comes to using both the equations, I've seen on other question papers, they will probably take equation 2 minus equation 1 or equation 1 plus equation 2 to get a certain variable of A or B. Is there a certain way to approach whether you should substitute 2 into 1 or 2 minus 1 or 1 plus 2?
Okay. All right. Good question, Nick. Here's my suggestion. And this is a question that has been recurring. Math has many ways. My advice, though, would be to use the substitution format, the one that I've just used here. This is because when you get to complicated questions, it becomes a bit difficult for you to do that word subtraction that you're talking about. Here I can actually do it. That's not a problem. I can actually do it. That is, for me, is not an issue. But I really honestly suggest that it does not happen. I suggest that rather do the substitution so that you learn it from the simple ones, and when you get to the complicated ones, you still use it. But if you're comfortable with this word plus, minus, because here you need to like multiply, I think multiply the equation number 2 by 3 and no, by 4 rather, to cancel off the a's, and then you take it up from there. So I'd rather use the substitution format itself. That's always the easy way out, whereby you are just saying, let me make a the substitute to the formula 2 into 1 rather than above 1 minus 2 or 1 plus 2. That's what I suggest to you, Africa. And then Ubandile has a question. Yeah,
so
go
I have
ahead,
another.
please. Yeah, go ahead. Go ahead.
Is it okay? Sometimes you end up with a simultaneous equation. Is that correct?
Yeah. Yes,
okay.
You do. Yeah, you do. End up with a simultaneous equation. Right. I want to unmute Bandile. There you are, Bandile. Bandile, I've unmuted you. Right, while Bandile is trying to connect, let me deal with Ulevo Khan and try to do this again. Level, the idea is this, ne? You're looking for the equation. Well, whatever you have, use it. I have 3 points. That's what I have. I have 3 points, Q, P, as well as -2 right there, right, for E, Y intercept. I have those 3 points. That's fine by me. I don't have a problem. I want to make sure that in my situation, I find A, B, and C. C is easy to find because C is the Y intercept, which is the point 0 and -2, which I'll take there. C is the Y intercept. So I already found my C, and I put my equation there with my C in it, which is this part. Fine. Then I'm looking for A and B, which I don't know. But I know that from this equation, this one, I'm clear that A and B can be found if I substitute the coordinates Q and P, the ones that I'm given. So in the first one, I substituted Q, right, the coordinates of Q, 2 and -2. I ended up here at equation 1. I knew I couldn't solve this normally because I've got 2 things that I don't know in one equation. So I must do it simultaneous. Substitute the other point, -1 and 1. There you are. I get the second equation. Then I do simultaneous, which is what I think Africa was asking me, right? And I do simultaneous. Then I just find A, B, C, I already have it. And it's exactly how they wanted me to do it. And I bang my 6 marks right there. Okay, beautiful. Let me go further, guys, on this one. If there's no other question on that, I'm taking this out now. Mandile, you still have raised your hand. I'd like to unmute you. Let's go. Mandile, go ahead. I really cannot hear you. Maybe it could be a network issue. I don't know. But while we're waiting for Mandile to come through, 3.12, show that R is the point 1 and -3. In the question itself, if you go to the top of the question, they probably told you that R is a turning point, and that's true. That's what they said. R is a turning point. Now, they want you to confirm that the coordinates of the turning point are 1 and -3. You are given the equation where R is, and I want you to know, when given the equation, Vandile, you can always type your questions, okay, I can read it. Okay, when given the equation of a quadratic, you can find the R there, the exponent of R by using this. Remember that the exponent of R is also the equation of the axis of symmetry, and that's how you find it, x squared minus b over 2a. So the exponent of R can be found minus b, where b is -2, then over 2a, my a is a +1. So in other words, it's going to be a +2 divided by 2. The answer is 1. So the exponent of R is 1. And that's what they say there, is 1. To confirm that the y coordinate is -3. So now I know that the x coordinate is 1. To confirm that the y coordinate is -3, just substitute x is 1 into this equation, because that's where R is after all. So now you're looking for the y coordinate. Confirm with me if I'm going to get this right. I definitely should. So my R becomes, my y coordinate of R becomes -3. And that's how you prove it and get your 3 marks in the exam. So remember that the x coordinate of the turning point, what is it? It is also the equation of the axis of symmetry. Also the equation of the axis of symmetry. Very important that you get that right. Okay, I'm going to take this out. Remember, this is our last question. Then we're going to stop through on that. Okay, let me just put it back just in case someone is writing. And all right, we keep going, family. We are almost at the end. Let me try the next one there. What does the next one tell me? The next one says to me, determine the equation of G in the form AX plus BY plus C is equal to 0. Now, G is the straight line, okay? The one equation of the straight line. So what do I have on the straight line? I've got 2 points, Q and R, on that straight line. So I've got Q, which is 2 and negative 2. I have R, which happens to be 1 and negative 3. And I'm looking for the equation of the straight line. All I need to do is to get the gradient. So the gradient is y2, negative 2 at the top, minus y1, negative 3 there. All this over x2, that's 2 minus 1. So y2 over x2, y2 minus y1 over x2 minus x1. Do the math. At the top here, you're going to get a 1. And then here at the bottom also, you're going to get a 1 as well. So the gradient is just 1. That's all. Talk to me if I'm making any mistake. Help me out. Bandile, I think you just sent your question. So you said, would I be right to make a substitute of the formula in equation 1 and then equate A in the equation 1 with A in equation 2? Yeah, that's fine. That's fine. But you see the problem with that one, with that one, you end up having a fraction, if you think about it. End up having a fraction, Bandile, so it becomes a bit of a problem. So it's okay. M is 1, gradient is 1, right? M is 1. Then you're looking for the equation. Y is equal to mx plus c. What is m? M is 1. Now to find c, simple, substitute either q or r to find c. So let me just take q, Mina. So y is negative 2, the gradient is 1, x1 is 2 plus c. So then that becomes now negative 2 is equal to a positive 2 plus c. So c becomes negative 4. But they want it in this format. Look at this. They want the equation in this format. So far, it looks like this. It's y is equal to mx, which is 1, x, right? And then plus c, which is negative 4. So it's like x minus 4. That's why. Now they want it in this. They want it equated to 0. That's what they want. There. Becomes easy. Just take x minus 4 to the other side. Y minus x plus 4 is equal to 0. And that's your answer. That's it. That's your answer. If you want to be very, very specific, do this. Here they started off with the x. So they just rearrange negative x. Then they went to the y, then plus y. Then they went to the c, then plus 4 is equal to 0. That's all you're simply doing. You're equating your equation, in this case, to a 0, as can be seen. So that becomes something that you can do. Okay, talk to me. Talk to me if you don't get this. I'll help you out. Okay, there we go. We're done. We're now going to the next one, which is the last one, 3.14. Write down the equation of the hyperbola. Write down the equation of the hyperbola right there. Write down the equation of the hyperbola. Maybe someone is still writing this. Oh, yes, someone raised their hand. Let me just see. Nicole, you raised your hand. I would like to unmute you, Nicole. Go ahead. Nicole?
Afternoon, sir. Can you hear me?
I can hear you. Go ahead.
Oh, yeah. 3.1.3 says determine the, that question. So in this way, sir, I've been trying to say that the other coordinates of a straight line is on the parabola. Because here it
Nicole,
says
I didn't get to
determine.
hear that. You said, okay, I don't know what's going on. Nicole, I didn't hear that. What'd you say?
I'm saying 3.1.3 says determine the equation of G in the form of a parabola, right? So, can you hear me?
Yes, I can.
So I'm trying to ask whether they're trying to say that the other coordinates of a straight line is on the parabola now.
Oh, okay, good one. Because now that's what I'm going to do. I'm going to do 3.14. And this is why I chose this question anyway. Because your parabola is one-sided. Usually you guys are used to a two-sided parabola, right? But this one specifically is one-sided, right?
Because,
Let me explain
because
what
now,
you do.
because now I'm confused that we're using the gradient while they're asking in the form of a parabola.
No, Nicole, I think you're confusing questions. I mean, I was doing 3.13 and I'm going to 3.14.
I'm asking for 3.13.
Uh-huh. And in 3.13, Nicole, they said write down the equation of G in the form this. In the form this. And that's not a parabola, that's a straight line form. It's just that you'd have equated everything to 0. Because if it was parabola, it was going to be x squared. You see that? All right, sharp, Nicole. I'm going to just quickly mute you on that one. All right, beautiful. I'm going to 3.14, guys, and that's a very interesting question. 3.14, and let's see how far it goes. Okay, I'm going to take this out now. You have a hyperbola. It says write down the equation of the hyperbola of H2 max. This hyperbola is one-sided. You're used to a two-sided hyperbola. So what do you do when you've got a one-sided hyperbola? This is what you do. You say K is equal to XY. K is equal to XY. Follow my lead, you'll be okay. Then since it's one-sided, the X and the Y is that coordinate on the hyperbola. That's the X and Y. That will help you to find K, -1, and then 1 here, then that's K. So in other words here, K is equal to -1. And so now I know what K is. It's -1 is equal to XY. Make Y the substitute of the formula. -1 over X is equal to Y. And that becomes your equation. Just that. When you've got a one-sided hyperbola, K is equal to XY. K, who's the X, who's the Y? Is the coordinate on the on the hyperbola. Then get your K, okay? And remember that, okay, you got your K, so what is K? It's -1 is equal to XY. Make Y the substitute of the formula by dividing both sides by Y, by X. So it becomes Y is equal to -1 over X. Then that becomes the equation of your typical hyperbola. Someone's got their hand up. And to be any day, I'm gonna unmute you. No problem. Fine, let me help you. All I'm simply saying is if you're given a hyperbola which is one-sided and you're looking for the equation, it's always K is equal to XY, right? Find your K. And X and Y will be a coordinate on the graph, on the hyperbola. And the only coordinate on the hyperbola I have is this one. So here I'll have it as -1 multiplies 1. Then that means then my K becomes a -1. So I found K. But I'm not looking for K, I'm looking for the equation of the hyperbola. So then for me, this becomes -1 is equal to XY, sharp. Then I'm looking for the equation. So every equation starts with Y. So divide both sides by X. Becomes -1 over X will become equal to Y. So the equation of your hyperbola will definitely be -1 over X. And what's interesting further on is that all your X values are less than 0. All of them are negative because your graph is on the negative X-axis. So you probably need to specify that as well. -1 over X, they're not less than or equal to 0. Guys, no, they're less than 0. If they were less than or equal to 0, this wouldn't make sense. That would mean that the denominator is 0, and that is not right. So it's less than 0 on the left-hand side. Charisma, you got a question? There you are, and also Ozianda. Go ahead. I've unmuted you. Should be able to hear this. I've unmuted
So
you.
can you hear me?
Yeah, now I can.
Okay, so I want to ask, is it possible that you may be told to write the equation of the hyperbola while you're not given any points on the hyperbola?
Oh, no, you can't. They probably would have given you asymptotes. No, to find the equation, you need coordinates. They would have given you at least something. Even if it's one thing, it still works. So no, you won't be asked to do that without knowing what's going on. They would have at least given you information. That'll be difficult, if not impossible, to find that equation and there's nothing about it. Right? They would have either give you the coordinates or they give you a point of intersection or whatsoever, but they give you something to work with. All right, that's what you have there. Charisma, they may have to, Zianda, I don't know where Zianda's gone to. I think her hand is up, or they, okay, there you are. I've asked to unmute you, go ahead.
Yeah, can you hear me?
Yeah.
Okay, so for the equation k equals xy, is it only for one side?
Okay, Zianda, I really think, I don't know whether it's me, but I can hardly hear you. There's like a bit of an echo on the speaker there. Uh-huh. Go ahead. Try that again, Zianda.
Can you hear me now, sir?
Now way better, girl. Way better. Go ahead.
Okay, so I'm asking the equation k equals xy, right? It's only for one-sided hyperbola.
Mm-hmm.
Yeah. So is it like standard or?
Yeah.
Okay.
For the two-sided is like this. This is the normal one.
Yeah.
But this one is standard.
Okay.
Yeah.
Okay,
Standard,
thank you, sir.
all the time. So it's just k is called xy. That's the same thing that I think one of the guys that sent me a message, he was asking me. It's a standard thing. This is actually from grade. There's another way of doing this though. This is from grade 11. Guys, when it comes to math, there are so many ways of doing stuff, eh? And I can't really exhaust them in 2 hours. And I can't be saying, because you're taught this way, so let's do it this way. Someone else was taught that way, let's do it. There's so many ways of doing this, but the concept is just the same. So it is standard when you've got one-sided hyperbola, as you put it across. All right, I've got 3 hands. Let me take that. Thank you so much. You're welcome. 3 hands and start with Unicole, then Ukilebukile, and then Nelisa, and then probably end it up there. You guys have been wonderful. Lebukile, go ahead. Okay, I've unmuted you, so I'm waiting for you.
Oh, hello, sir. Are you talking to me?
Yes.
Oh, it's Ria.
Yeah, I've unmuted you.
We didn't cover transformations today, and that's.
Yeah, I didn't cover transformation of graphs because I'm going to do a video on that. That one is definitely, I'm going to do it. Definitely I'm going to do that. Transformation of graphs. I don't even need to do, I'll show you examples of it, okay? That's all you need to do. So what I wanted to do initially was not to do our f of x g of x, but I thought they were so important. That's why I did them in this lesson. And then I will cover transformation of graphs probably sometime, maybe this weekend, and send you a video to the groups and you guys can have that. Okay, there you are, you have it. Who's next? There you are, I've unmuted you. Yeah.
Okay, I wanted to ask that since it's a one-sided hyperbola, won't they ask us about the asymptote?
The asymptote is there. You can literally look at it. This graph does not exist on the x-axis and on the y-axis. So the boundary is the y and x-axis. They won't ask you about that though. That's why the questions are usually 2 marks, 1 mark. But if you were to look at it, this graph here has its boundary. Let me just draw it here quickly. Let me use a different color pen. Let me use red. This graph here, this is the boundary wall, and that one as well. So the asymptote here is x is equal to 0. Here is y is also equal to 0. And it makes sense. Look at it this way. Look at it. Look at the equation, -1 over x. And usually you're supposed to have minus something and plus something. But there's nothing. There's nothing. There's zeros. So it means, therefore, the asymptotes are at x is 0 and also at y is 0. That's the boundary of this particular hyperbola. Okay, that's fine. Are you okay with that?
Yeah, but thank you.
Okay, Sharp, you're welcome. I don't see anyone else. Let me do this, stop sharing, and then come back to this. Okay, family. Thank you guys so much for today. You guys have been wonderful. Thank you to the Facebook family as well. You guys have been wonderful on this. This is not the norm. I just did this because I thought you guys would need some help. And yeah, this was our first attempt. I am going to do another one. I think next week, Wednesday, I'm going to do physical science. I want to do vertical projectile motion. Should be able to send the documents on the groups and everything. You guys have been really wonderful, and I hope this was very helpful to you. And just work hard, family. Let's keep pushing wherever we are. Let's never give up on ourselves. You need help. Definitely, I'm going to put my number here, even on Facebook there, using that link that you have. That there's a page there, you can follow that page. I'm also on Instagram. You can follow me on Instagram. And then on the YouTube channel, I'm quickly, as soon as this thing is done, this lesson, I'm going to close it, then convert the video, then upload it on YouTube, then send it to you guys. You can watch it at any time, and you guys can do what you need to do. Let's have a great evening, people. Say thank you to your parents who gave you data. Thank you to your friends who also helped you out. Thank you to everyone, and thank you for your participation. God bless you all, and let's have a great night. I'm closing this. Goodbye.